Hello everyone, welcome to my new video. In this video, we'll be learning about trigonometric limits. In trigonometric limits, we generally come across two types. In this video, we'll be looking at type 1. In type 1, the limits that we have is of the form limit x tending to 0, and the special thing about type 1 is that our limit will be tending to 0, or our variable will be tending to 0. And the function that we have is f of x. So we need to evaluate this limit for this function f of x, and since we are looking at trigonometric limits, this function of x will be trigonometric, of course. Okay, to solve these type of limits, we generally use two results. The result number 1 is limit alpha tending to 0 sine of k alpha divide by alpha is equal to k. So that's the result number 1. The result number 2 that we will be using is limit alpha tending to 0 tan of k alpha divide by alpha is equal to k, and this k is nothing but some constant value, so k is just a constant. Okay, so one important thing that I would like to highlight over here is that the angle alpha, or our variable, so the angle alpha or the variable, especially in this formula, it's mandatory that it has to be in radians. So it's mandatory that to use this formula, or in order for this formula to be valid, alpha should be in radians. And if it is not in radians by any chance, we will be using alpha degrees. So if it's in degrees, we will use this conversion. Alpha degrees is equal to pi over 180 alpha radians. In order for converting this from degrees to radians, we will be using this formula, but it's very important that alpha has to be in radian while using this formula. Okay, let's look at some of the trigonometric results that we will be using in these type of limits. So the first type of formulas that we will be using while doing the trigonometric limits are half angle formulas. In half angle formulas, there are two really important formulas that we frequently use. The first one is 1 minus cos 2 theta. So 1 minus cos 2 theta, if you remember from your trigonometry chapter, 1 minus cos 2 theta is 2 sine square theta. And the key takeaway over here is that our angle becomes half. So since it was 2 theta, it will become theta, since they are half angle formulas as the name suggests. Okay, can you guess what will be 1 minus cos theta? So it is a similar structure, just instead of 2 theta, we have theta over here. So our result will be 2 sine square, and that angle will become half. So if it is theta, the angle will be theta by 2, and that's because it's a half angle formula, so our angle will become half. Okay, we do have the formula for 1 plus cos 2 theta as well, and this is nothing but 2 cos square theta. And the key takeaway over here is again the same, since it is a half angle formula, the angle becomes half. And can you guess for again 1 plus cos theta? This will become 2 cos square theta by 2, as the angle became half. Okay, so these are the key half angle formulas that we'll be using. The other type of formulas that we'll be using are factorization formula. So in factorization formula, we have 4 results. So the first result is sine alpha plus sine beta, and we will look at how the formula becomes. The other result is sine alpha minus sine beta. The third one is cos alpha plus cos beta, and the final one is cos alpha minus cos beta. Okay, so let's start to build these formulas. All the formulas start with a 2. So all the formulas will start with a 2, and they are followed by, so the first one, sine alpha plus sine beta, the formula becomes 2 sine alpha plus beta divided by 2 into cos alpha minus beta divided by 2. So sine plus sine becomes 2 sine cos, and sine minus sine on the other hand becomes 2 cos alpha plus beta divided by 2 into sine alpha minus beta divided by 2. Cos plus cos becomes 2 cos alpha plus beta divided by 2 times cos alpha minus beta divided by 2. And cos minus cos, this is the only formula that has a negative sign. So it is negative 2 sine alpha plus beta divided by 2 into sine alpha minus beta divided by 2. So these are some of the important trigonometric results that we will be using frequently while solving trigonometric limits. Okay, so let's look at some of the general steps that I like to follow while solving the type 1 of trigonometric limits. We'll also be looking at the example simultaneously so that we understand how to exactly apply these steps in a live example. Okay, so there are 3 steps really. Step number 1 is check the degree of 0 in the denominator. So what does this mean? So let's say in this example, in the denominator we have x squared and x is tending to 0. That means in the denominator we have 0 squared. So for this example, the degree of 0 is 2 in the denominator. So in the denominator our degree of 0, so I'll write over here degree of 0 is nothing but 2 since it is squared. Okay, so that's step 1. Step 2 suggests use the trigonometric formula to get equal degree of sine or tan in the numerator. So since the degree is 2, we will try to use some trigonometric formula in the numerator in order to get the degree of sine equal to the degree of 0 in the denominator. So since the degree of 0 in the denominator is 2, we will try to get the degree of sine as 2. In fact, sine or tan, but in this case, as you can see, 1 minus cos is going to give you sine. It will give you 2 sine terms that will make the degree of sine as 2 in the numerator. Okay, so let's look at this. So if we apply, let's try to solve this limit. So this limit will become limit x tending to 0 1 minus cos. So 1 minus cos is, as we looked at in the previous slide, 1 minus cos is 2 sine square mx divided by 2. The angle becomes half, so that mx becomes mx divided by 2 divided by x squared. So I hope the first 2 steps are clear. The first step was check the degree of 0 in the denominator, and the degree of 0 in the denominator is 2 since it is 0 squared. It is kind of looking a 0 squared. In the numerator we will try to bring a squared term of sine or tan, both are okay. And in this case, it was possible to get the square of sine in the numerator because of 1 minus cos. Okay. In the step 3, we really want to use our trigonometric results, sine kx upon x, which is k for limit extending to 0. Before that, let's take this 2 outside of limit since it's a constant. So since it's a constant, I'll take it outside. So 2 limit extending to 0 sine mx divided by 2, and there is a square on it actually, and divide by x. There is a square on this as well. So I'll combine these and write whole squared. Since there was a square on sine as well as the square on x, so I'll just combine those and write the whole square. Now this will become, now if you observe over here, this is like sine kx divide by x. So it is of this type, sine kx divide by x, where k is m by 2. So this will really become 2 limit x tending to 0. Oh, in fact, I can get rid of the limit now because I have the result. So this will become sine kx upon x, which will give you k. So 2 into m by 2, which is your k, and there is a square on this, and this will become 2 m squared divided by 4, and you can really cancel 2 in the numerator and denominator. That will give you m squared divided by 2. Okay, so let's look at few more examples so that we clearly understand how to apply the formulas that we did in previous slides as well as the steps we learned. Okay, so in this one, it says find the value of limit x tending to 0 sine mx over tan nx. We know that our formulas are limit x tending to 0 sine kx divided by x is k, and limit x tending to 0 tan of kx divided by x is k. So this is kind of a side note. So these are the two formulas that I know. So if you observe, you have one thing missing, is x in the denominator. So there is no x in the denominator. So what I can really do is divide numerator and denominator by x. So I'll divide numerator and denominator by x, and my limit will become limit x tending to 0 sine mx divide by x. So this is dividing numerator by x, divide by tan nx divide by x. So this is dividing numerator and denominator by x, and since I'm dividing by x, I need to give a reasoning on the right hand side that this x is not 0. So since I observe that x is tending to 0, so I know that x is tending to 0, and which means that x is very close to 0 but x is not 0. If x was 0, I cannot divide the numerator and denominator by 0. So it's kind of a good practice to give reasoning on the right hand side that the number that you are dividing by is not really 0. So it's okay to divide basically. So we'll split the limit in numerator and denominator. So you have limit x tending to 0 sine mx over x divided by limit x tending to 0 tan nx divided by x, and using these results over here we can say that numerator will become m since this is like sine kx divided by x, and k is nothing but m over here, so this will become m and the denominator will become n using these results. Okay, let's look at another example. In this one it says find the value of limit x tending to 0. So this is the first hint that it is our type 1 of trigonometric limit, since it is tending to 0 and the terms look like the trigonometric terms to me in the function, so it becomes the type 1 of trigonometric limits. Okay, and it says 2 sine x minus sine 2x divided by x cube. Let's try to follow our 3 general steps in order to solve this limit. Okay, so step number 1 was check the degree of 0 in the denominator. So in the denominator, since I have x cube and x is tending to 0, that means I really have 0 cube. That means that degree of 0 in the denominator is 3. That means that I will try to get in step 2 equal degree of sine or tan in the numerator. And since I see a lot of sine in the numerator, my goal should be to get the degree of sine in the numerator as 3 using my trigonometric results. So let's see how we can do that. So I notice there is a sine 2x, and if you know, sine 2 theta is nothing but 2 sine theta into cos theta. Okay, and remember that our goal is to get degree of sine as 3 in the numerator. So let's start to solve it. Limit x tending to 0, 2 sine x minus this sine 2x can be written as 2 sine x times cos x, and this came from this result over here, divide by x cube. Okay, so this can become limit x tending to 0, and if you notice I can factor out 2 sine x from these terms or take them common. So I'll factor out 2 sine x and I will be left with 1 minus cos x divided by x cube. Right now if you notice in the numerator the degree of sine is 1. Can you guess how can we make the degree of sine as 3 in the numerator? Yes, you guessed it right. We have 1 minus cos x and this can give us 2 sine terms. So this will become limit x tending to 0, 2 sine x and 1 minus cos will become 2 sine square, and this angle x will become x by 2 since it was a half angle formula, divide by x cube. Okay, since it is a x cube and I have power 1 over here and power 2, so I will split this into x and x square, and the first sign will get x and the second sign will get x square because of their degrees. So we have limit x tending to 0, 2 sine x divided by x, and we have 2 sine square x by 2 divided by x squared, and the 2 times 2 can become 4, so this 2 times this 2 will become 4, so we have 4, and we can split these limits into these terms, and we have limit x tending to 0, sine x over x times limit x tending to 0 sine x by 2, and there is a square on this, divide by x, and there is a square on this as well, so I will combine that squares to write the whole square. Okay, so I will get 4 times, so this first limit sine x over x is like sine kx over x, where k is 1, so that will give me 1 times, even the second limit looks like sine kx over x, where k is nothing but half, so k is my half for second limit, so that will give me half squared, so that will give me 4 times 1 is 4, and half square is 1 by 4, and I can cancel out this 4, and my answer is 1.